Okay, so today we'll continue talking about the environmental control system, and next subsystem of this system will be connected with the ventilation, with the temperature regulation, and as a result with a pressure regulation on the board of passenger aircraft. So previously we talked about the bleed system, the system that supply air taken from the engines, from the EPU, and we discuss a principle of air conditioned pack operation that cool down air for next supplying for our subsystems. And in our case we talk about ventilation and pressurization system. Then you may see a green manifolds that redistribute the air along the fuselage. And idea of this system to supply a fresh air. As we said before, 0.28 cubic meter per minute must be supplied for each occupant on the board. And if you have 100 occupants, you will multiply it on this value and obtain 28 cubic meter. To save some air, bleed air, because bleed air is air that is taken from the compressor, so we take this air for the purposes of passengers, for the people on the board, and we take a part of engine thrust in this way, and we need to burn fuel for the purposes of passengers. So that's why you may find an air circulation system in some airplanes. It may keep during flight up to the 50 fresh air from the supplying volume. So we will use an air from the cabin, we will clean it and return it to our users. So what we shall to know? Cabin temperature control is the first one function, the main function. We are interested with the regulation of temperature by the zones. Typically, aircraft has a few zones. In most cases, there are 3 zones: for cockpit, for forward part, and for the aft part of fuselage. And it could be more, or it could be 2 zones, or sometimes it will be enough only 1. But a separation on the zones give us an capability to regulate air directly for the each individual zone. In what way we will provide it? First main idea of the temperature regulation. We haven't heaters, the units that will use the energy, for example electrical power, for heating the air in the cabin. We use a principle of mixing. We will mix cold air from the air conditioned packs with hot air that is going outside the air conditioned packs manifolds. And I hope you remember that we call it as trim air. So trim air, it's a hot air that wasn't cooled down in air conditioned pack and is going by the separate line, and this trim air could be mixed with cold air. So after air condition pack. The air, cold air, is going to the mixer unit. You may see this mixer unit in our diagram here, or mixing chamber. So from different air condition packs, the air goes going to this mixer unit. Then from this mixing unit, by 3 lines, separate lines, air is going to the cabin. If you want to increase the temperature of this air, you will mix cold air from mixer unit with trim air, and depending on the temperature level that is predetermined by the pilots, you may mix it more or less. So in this example you may see a total opened valve. In this it's a partial opened. So temperature here will be less than in this case. For crew cabin, you may see the trim air is totally closed. So we use a cold air from the mixer unit to keep a cold regime for flight. Also, you may notice that we have some special arrows that show us that some portion of air goes to the mixer unit from the cabin. This is a recirculation subsystem. But before we'll talk about recirculation system, let's a little bit discuss the principle of temperature regulation from the point of view of gauges that will control the temperature. First of all, in most of airplanes we will use the skin temperature sensors. They are installed on the inside part of fuselage skin, and it contains a sensor element that may transform a temperature into the changes of the current signal. And due to the changes of this electrical outcome and signal, you may determine a temperature of aircraft. And here you may see a typical location of such sensors. Other sensors are installed in the ducts, and you will measure an air temperature directly, temperature of the air that is guided to the cabins. And the principle is the same. Due to the changes of electrical signal outcoming, you will determine a temperature in the system, in the vent duct. And by means of the knowledge about these two temperatures, you may find an outcoming results. What about cockpit air supply? So for purposes of flight crew, we need to provide additional functions, not only the temperature control. And it is connected also with protective means, protective of the windshields from the vapors, from the ice formation. But we talk about the inside controlling, so we talk about the protection from the vapors appearance on the cold windshield. So you may notice that air is going through these pipelines and is heat and remove a condensation from the windshield. For this system, you may notice that we use additional sources of heat, electrical heater. So it's mean that for special purposes we may use electrical heaters. If we talk about the ventilation, we just use a principle of mixing cold and trim or hot air. Then, for some special zones in aircraft, and as example in the galley area of Airbus 330, you may find additional heating system. The function of them locally increase the temperature of air in the aft galley area, and we use it for the protective means. This heater, it's an electrical heater that is used alternate current three-phase electrical system, and may generate up to the 1 kilowatt, and it may control the air temperature in the outlet up to the 50 degrees of Celsius. And it's a not typical, but it's in a special purpose heating system. And as an variant, you may control an density of the water presence in this compartment. Other variant of additional heating system that may be on the airplanes, on example of 737. They are installed in the zone of entrance door, and they use for the distribution of the heated air in the passengers compartment, and it may be aimed for the purposes of controlling of the slug or water on the for example floor that may be appears when passengers make a first step on the board, and from their shoes, for example if it is rain or snow outside, so some spillage of water may appear. By means of heater you may regulate this problem. What about the cabin air distribution? The main problem is to redistribute the air proportional to the volume of the fuselage along its structure. And for this reason, you may see that it will be a number of manifolds that are used for the air redistribution. And also you may provide two variants of the ventilation. It may be individual ventilations that are used by the passengers directly, and cabin ventilation that keep and normal conditions on the board during flight. So it's points through which the air income in the cabin, and also we have the points through which the air goes out. So here you may see so-called dado panel, decompression panels. Typically it is going through this space and goes to underfloor compartment, and then it may be dropped out through the pressure regulating controlling valve. But in case of decompression of the cabin, it may be situation when the difference of pressure between underflow and overflow compartment may be significant due to the rapid decompression. And to avoid any significant damages of aircraft structure, floor design, we need to use these protective means. So it is easily removed panels that will be blown out by the difference of pressure that may appear during the decompression. So they will be blown out and you have huge capes through which a pressure will be equalized. Next, as I said before, we may use the air from the cabin for the recirculation. But there are some specific points, specific compartments in our cabin, like galley and toilet. We have a line that provides ventilation in this compartment, but we will not use the air from the galley and toilet for the recirculation system. We just take it from the separate manifold and we will drop this air out by means of extraction fan, electrical driven fan, outside. And here you may see this air extractor. So one of the significant element of it, it's in a jet pump or venturi tube. As you remember, in fuel system we use this principle for the fuel transmission. We use active fuel, pressurized fuel that is guided to our venturi tube, and we will use this principle here. We will use an air from the driven by the pump or flow compressor, and the difference of pressure that will suck air from our compartments. And in this manner we will increase air flow through the system. And on this picture you may see an installation of such air extraction unit on the board. So we have a galley air inlet that will connect it with a separate unit, and then by the extraction duct it is going outside from the cabin overboard. For some airplanes we are using emergency system for the air ventilation. On Airbus 320 as example, when you will study your laboratory work, please pay attention on it. We have emergency ram air system. Idea is simplest one. If you will have a problem with an air conditioned pack or with bleed system, so you haven't sources of fresh air, you may deploy emergency ram air inlet flap, and through this emergency ram air inlet flap the air is incoming in the mixer unit, and after that you may redistribute it through the cabin compartments. And by the way, please look on this diagram. You may notice a button, ditching. As you remember, ditching, it's a process of landing of aircraft on the water. Why we need this special button here? To avoid a problem in case of emergency landing of the water that is connected with the water incoming through this emergency ram air inlet flap on the board. So before emergency landing on the water, it will be automatically closed. Then avionics ventilation. From the point of view of avionics operation, it releases significant amount of heat, all electrical equipment, especially avionic equipment. And if we talk about some transformators, and we need to provide a cooling of this compartment, and you may see that for these purposes you supplementally to main ventilation system you may use the avionic ventilation system. And if we will simplify our diagram, you may see that we use outboard air that is blown by the fan in the avionic compartment and extract fan that take hot air or warm air and guide it outside through the flap. Depending on the purposes, we additionally have a possibility to regulate an air by means of controlling position of regulator valves that may also provide a circulation of the air in the cabin, avionic compartment cabin. And recirculation. As I said, we want to save money. We would like to reduce the fuel consumption that is taken for the providing a bleed air generation for the purposes of passengers on the board or occupants. And for this reason, I think all airplanes with more than 30 tons takeoff weight or 40 tons takeoff weight have such system. So it is widely used system on the board, and idea is simplest one. You will take air from the cabin, you will guide it on special filters, HEPA filters, and 99.9% of any pollutions, particles, dust in the air will be trapped in these filters. To provide its operation, we need recirculation fan. It is driven by the alternate current motor. We need valves that will control an air supply, and we need filters. Filters are so-called hard time elements. Hard time, it means that it is limited in its time and periodically it must be replaced. Depending on the type of the airplane, it may be from the 1000 to 3,000-4,000 of flight hours. Okay, so next subsystem, it's in a cabin pressurization. So pressurization of the cabin connected with the nested to keep a normal pressure for the occupants, because with increase of altitude the pressure decreased, and in the cruise altitude of approximately 11 kilometers the pressure will be in 5 times less than on the ground. So it will be difficult to withstand for a long period of such conditions. As a result, if decompression happens, or if a person will be on this altitude, he may die due to the hypoxia, a lack of oxygen in the blood. So, what we should know about the pressurized cabin? First of all, when we talk about the pressure in the cabin, we will not use units like pascals, like kilograms per square inch or centimeters and so on. We are using altitude. So when we discuss the pressure in the cabin, we will use an altitude. As I said, the altitude directly connected with the pressure. With increase of altitude, pressure decrease. And it has a linear dependence. So that's why we may apply this approach. And it will simplify the life of pilot, because they used to think about flight in the meters per hour or kilometers per hour, altitude of flight in the meters, distance in kilometers, and so on. So that's why I think they applied this principle for cabin pressure. What we need to know about the pressure cabin? First of all, we decided to do not keep the pressure of the cabin or in the cabin the same as on the ground. We will decrease this pressure, and we need to decrease it, we must decrease it from the point of view of the strength. In this manner you reduce loads on the structure, so you may make it lighter, because the strengths depend directly from the weight of the structure. So the next question was next. What is the value of this decreasing may be appropriate for the passenger? And medical study show us that it will be approximately decreasing on 25%. So if we will use an atmospheric pressure for the description of normal environmental, 1 atmospheric pressure, 1 atmosphere, so decreasing on 25% give us 0.75. And we know that with increase of altitude the pressure decrease. If you are going on the mountain on the altitude of 8,000 feet, that is approximately 2.4 kilometers, you will reach this pressure 0.75 atmosphere. So it was decided that pressure in the cabin must be equal to this altitude and must be equal to this altitude during all cruise flight. So when a plane is flying on the altitude of 11 kilometers, the altitude, so-called pressure, the altitude in the cabin will be 2.4 kilometers or 8,000 feet. Additionally, if your airplane flying on the altitude more than 25,000 feet or 7,600 meters, in case of probable failure or malfunction of pressurized system, you must keep pressure that will be not less than pressure on the altitude 4,572 meters, that is equal to the 15,000 feet. What does it mean? Independently on the altitude of flight, will you fly on 6 km or 12 km, you must maintain a pressure altitude in the cabin equal to the 2,400 meters. But if you will fly on the altitude more than 7,600 meters, you must provide additional requirement for possible problems that are connected with the pressurization. You must provide a keeping altitude not more than 15,000 feet. Typically, it is realized by closing all outflow valves. We will discuss them later. What about the valves? We have different types of them. We have outflow valves that will regulate pressure on the board. Typically, we will regulate it by means of controlling air outcoming. If you need to decrease pressure, or in other words, increase a cabin altitude, you will open it widely. If you need to decrease this rate, so you need to decrease altitude, you will close these valves. So it's an outflow valve, but something may go wrong and you need to protect your system from the malfunctions. For these purposes, we have not less than 2 pressure relief valves. They are fully automatically operated system. They haven't any controlling elements. Just they keep a balance between difference of pressure and spring loads. Then 2 reverse pressure differential relief valves, and they are used to protect our cabin if the pressure inside will be less than outside, because pressure relief valve protect our cabin when the cabin will be over pressurized, when the pressure inside will be more significant than it was designed, for which value it was designed, the structure. So to reverse pressure differential relief valve keep our structure safe from the collapsing. And it's in a simplest design, so that's why we may apply one valve. Sometimes one valve is enough if the dimensions and cabin volume will be not so huge. So sometimes we have a means by which the pressure differential can be rapidly equalized to make a pressure inside and outside equal, especially if we have a decompression or some malfunction in the cabin, or maybe after the landing. And we need an automatic or manual regulator for controlling intake or exhaust airflow, or both, because the balance between incoming and outgoing air provide a necessary level of pressure on the board. So we need, for monitoring of these parameters, pressure differential. It shows us the difference between pressure in the cabin and outside. It may be in the range of 8-9 psi, pound per square inch. The cabin pressure altitude, and it shows us the current value, and typically during normal flight it shouldn't be more than 2400 meters. And the rate of change of cabin pressure altitude, the speed of change. Next, also you need warning indication, because unpressurized cabin, it's in a potential problem for our operation. So what we need to know, when we will exceed 3 kilometers, I mean pressure in the cabin, when the pressure will be less than pressure on the altitude of 3 kilometers, so it gives us an oral or visual signal. Typically you may see a master caution light that announces us about possible problems. And additionally, on the cabin you may find a warning placard. A warning placards show us boundaries or limits that may be achieved during flight, and maybe some additional requirements that must be taken in account for flight. So it may be connected with pressure differential, or maybe a restriction in the rate of change of cabin. So, and also pressure sensors, and this system must provide the outcome of this information without delay. If you will look on this diagram, you may see a principle of pressure regulation. Green line, it's an airplane pass flight. Magneto, light line, it's a line that shows us changes in the cabin. So you may see that the pressure in the cabin increase before taking off. Pressure increase, but altitude decrease approximately on 3000 feet. It means that we additionally pressurized our cabin. What is the reason? It improve or increase a level of comfort of passengers on the board during takeoff, because during initial roll of airplane, when we goes up, you may notice a sudden increase of pressure that will strike our ears. To avoid this pain in our ears, we will slowly, before takeoff, pressurized cabin. and then proportional to the vertical speed we will change an altitude in the cabin up to the 8,000 feet. Then before landing we also provide the keeping of the proportional rate of changes of altitude on the cabin. When we will reach approximately 10,000 feet, 3 kilometers here, 10,000 feet, approximately 10,000 feet, and a cabin altitude warning light will appear. It will announce that you need to check an operation of the system. And if you could not keep a normal pressure in 15,000 feet, outflow valve will totally closed, trying to keep and remaining air for the pressurization. And you may see an original flight path of airplane, and it shows us some more nature for real life behavior of airplane. So we are going on the cruise altitude, and it could be due to different reasons. Maybe airplanes near with our airplane, so we need to change the altitude and so on. You may see that this cruise altitude is not straight line, but an altitude in the cabin must be like a straight line. We keep it approximately on 8,000 feet. But sometimes it could be situation when, for I don't know, maybe it was bad weather or thunderstorm or something like that. So airplane goes on the highest altitude, and differential pressure between the altitude pressure and the pressure in the cabin will be significant, more than the value that is predetermined by the design of strength. So in this case you may see increasing in the altitude. The main reason to keep this maximum differential pressure, because if we will continue provide the same altitude, the same pressure, the differential will be higher and damages of the structure may appear. So from this point of view, cruise altitude in the cabin is not main component that must be taken in account. The most critical is differential pressure. For cabin pressure sensor, we will use some special devices. It could be different variants, but here you may see a vibrating device, and inside we have a physical body that is vibrated, and it has its natural frequency. Under these conditions, environmental conditions, and pressure of the air, it has some predetermined frequency. With the changes of altitude, parameters of air changed and frequency will change too. So the frequency of vibrations directly depends on the environmental. And partially it is connected with the temperature, so we need to keep in account also temperature parameters as an element that avoid error in calculations. So example, when something goes wrong with a pressurized system. In this case, you may see that we have an airplane that is checked for the leakages during maintenance procedures on the ground. And for these purposes, we will pressurize our cabin with the air on the ground and maintaining the difference of pressure that will be on the altitude. And then we will check an air during which the pressure will be lost. If it will be in the boundaries, so your airplane is sealed well. If it will be in a short time, so something wrong with your sealants, with doors and other elements. When maintenance staff check the cabin, they not pay attention on the gauges, parameters of the pressurized gauges, and they over pressurized cabin that lead to the explosion of the fuselage structure. So I want to show you that it is very sensitive element and you may destroy it in simple way. What about the cabin pressure sensor? So in most of the airplane it is located in a separate unit, liner replace unit, LRU. So it is a cabin pressure controller. It's a block that is installed in the compartment, avionic compartment, in different places it could be. And it has built-in sensor, cabin pressure sensor. So it will determine a pressure in this compartment and then give a signal about the pressure on the board. We use minimum 2 of them. And also they have different type of bite test, built-in test equipment. So when we will press a test unit, test button, it shows you an information about the statement of this component. It is most advanced, and it shows you a message: controller LRU failed. But it could be just a red lamp that will announce that something wrong with your block. Next, when we talk about the pressure control valves, we have an outflow valves, but we have a protective valves, positive pressure relief valve. So when we will reach difference, it depends on the airplanes, but typically the maximum value is 8.3. For some airplanes it could be up to the 9 psi. By the way, as you remember, so reason why the altitude increased, it's a positive pressure relief valve operation that drop air outside and increase the altitude. Pressure equalization. In most airplanes they are located in the cargo compartment, and they keep the air pressure in the cabin and cargo compartment the same, because as you remember, the difference of pressure may be a significant factor for the strength of the integrity of the cabin, and it should be not more than 0.5 psi. And negative pressure relief valve, when the pressure in the cabin is less than outside. And it could be connected with an improper operation during the landing. Here you may see example of the location. So this is a cabin pressure relief valve. It's a separate block that monitors by itself the pressure in the cabin. Cargo pressure equalization valve. It's a spring-loaded simplest valve. If the pressure over the floor will be higher, it will push it down, this left valve. If the pressure under floor will be higher, it pushes it up and the air goes from this compartment to upper. And negative pressure relief valve. It's a spring-loaded valve that is installed in the fuselage and is opened when the pressure in the cabin is less than outside to avoid a collapsing of structure. Blowout panels. Inside the cargo compartment or underfloor compartment you may find these blowout panels. Again, if you have a decompression, to avoid any collapsing of your walls that will separate compartments in underflow level. And they will be blown out by this difference pressure, and you will obtain a direct access from one compartment to other. Pressure control valve. We have a few of them. On 777 Boeing you may see forward and aft outflow valve. Also you may notice a position for negative pressure relief valve and positive pressure relief valve. What is the principle of the operation? In Airbus, in Boeing, in modern airplanes, it is electrical driven motors, vanes that are opened or closed and by this principle we may control an incoming of the air or outcoming of the air from the airplane. So example of pressure control valves and their location, and you may notice some special pipelines that connects our valve with atmospheric pressure, atmospheric air, these holes. And here you may see on Airbus 330 outflow valve in open position. So here you may see on the fuselage, you may see a negative pressure relief valve. You see a spring rods, 4 spring rods. So it's the simplest type of protective means. When the pressure outside is higher than inside, the difference of pressure will act on this plate and push and compress springs. And safety valve. When the pressure inside will be higher than outside, it will protect it from the overpressurization. So here in more details you may see its design. We have electrical motors that provide a motion of linkages that will open or close our gates. and you may see them in open position on the fuselage board from different points. So here you may see safety valves, two safety valves, and outflow valve that is located on the pressure bulkhead. So position of them will be different dependently on the type of airplane. Other outflow valve in the forward compartment. And other example of the shape. It's an outflow valve with electrical driven motor. It's an negative relief valve. Not negative. This is the same without, but with different types. And this is pressure relief valve. So what about the safety valve? How it works? Normally it is closed. To determine abnormal condition, we need to compare atmospheric pressure with cabin pressure, and it is compared on this diaphragm. So atmospheric outboard pressure goes inside from this side and cabin from this side. This diaphragm will be additionally spring loaded, and when you will reach a difference of pressure dependently on the type of airplane, but approximately 8.3 psi, so when you will reach it, the cabin pressure will push our diaphragm due to the overcoming of the spring loads, and this diaphragm will pull left metering valve. So it goes to this point, and this ball will open hole here, and it means that the air that was stored in this inner part of the valve now may goes out. So here you may see that air goes through this channel outside, and pressure here may decrease. So we cannot maintain high pressure here, and it means that the cabin pressure also will act on this chamber and push it left, and we will pull our valve, and now you may see the gap that appears between fuselage skin and valve. Now the air from the cabin may goes outside. Here it is closed when the pressure is normal, difference of pressure is normal. So such type of safety valve has any control units. I mean, they are not controlled by the pilots or somebody else. It's a fully autonomous and independent system. So what you may see on this slide, it's a control unit that shows us a position of the valve, pack flow valve. Normally it must be opened, and then you will control air flow, normal, low or high As you remember, we must provide 0.28 cubic meter per minute, but some airplanes may regulate the outcoming of air. Then you will regulate an temperature in the cabin. As I understand, we have two subzones in this airplane. And hot air. This push button will control air incoming from the bleed system. As you remember, in bleed system, after the compressor stages, we have valves. And if you want to close them, if you don't want to take air from these valves, from this compressor, you must push this button. Then on this diagram you may see pack 1, pack 2, air conditioned pack work properly. I don't know why, but I guess for the example they show that ram air duct is opened. Typically it is used for the emergency situation. Then you may see that avionic vents work properly, fans work, and you have an outflow valve that work also normally. About the regulations, we control three types of parameters. It's a difference of pressure, delta P. Now it is equal to 0. I guess we are staying on the ground. Cabin altitude, it is near to the 0. And cabin changes velocity in foot per meters. So you may see that we also restricted in the changes in the cabin. So you couldn't rapidly change it in normal mode. Then other example of controlling in variant of 737. What we may see here, so you may see a round indicator that show us difference of pressure. Yellow boundary show us an dangerous zone. And here you may see an altitude in the cabin. If you will multiply it on 1000, you will obtain a value in the feet. So that's all about this system, and please welcome your questions.